Hello everyone, this is Ajay and in this video I am going to discuss a few questions from CET 2025 chemistry paper. Okay, so this will be helpful if you are preparing for CET chemistry or any other university entrance exams related to chemistry. This session is highly helpful and if you like the content please share with your friends. So let's start the video.
So the first question here is benzyl fluoride upon treating with H2PDPaSO4. So what is the name of this catalyst here or this reagent whatever they have used? So it is called as Lindlar's catalyst. What is this? Lindlar's catalyst. So what is the use of this Lindlar's catalyst? Yeah. So it will convert acyl halides to aldehydes. Okay. So it means if we have benzyl chloride here, benzoyl chloride. So this will be now converts into benzaldehyde. Okay, so this is what the conversion takes place when we use Lindlar's catalyst. That is what H2PDPaSO4. Okay, so here BaSO4, barium sulfate, act as a catalytic poison. Okay, right. Now one more thing here you can remember, Lindlar's catalyst is also used for conversion of alkynes. Okay, alkynes to cis alkenes. Okay, so what is the use of this Lindlar's catalyst? Yeah, we are going to get a cis alkenes as a product. Okay, and if you want to get a trans alkenes from alkynes, we can use bridge reduction. Okay, remember these simple important name reactions. Okay, right. So yeah, so here as per these they have mentioned Lindlar's catalyst. So this is what the A product formed here. Okay, now this is treated with acetaldehyde in presence of basic medium, right? So NaOH. Okay, now here you might be having doubt that NaOH, like it can act as a both as a nucleophile as well as a base. Okay, so now generally NaOH shows a basic nature whenever there is an acidic proton. If there is no acidic proton in the given substrates, then it will act as a nucleophile. Okay, so now see here the alpha hydrogens of this carbonyl group are considered to be acidic proton. So upon abstracting this proton, we are going to get a conjugate base, a carbon anion, something like this. Okay, so this can be stabilized by delocalization. So that's why this carbon anion is formed. Now, what is the reaction involved here? See, both of them are aldehydes, but here benzaldehyde has no alpha hydrogens, but acetaldehyde has alpha hydrogens. Alright. So this is nothing but a cross-order reaction. Okay, cross-order hybridization we can easily consider to be as Colwell-Smith reaction. Okay, so from this, yeah, we can directly have options here. Anyways, let me finish this. So this will attack over here, and we are going to get a beta hydroxycarbonyl compound OH, H, and this is CH2 COOH. Okay, now this upon heating, upon dehydration, what happens? This alpha hydrogen, because it is an acidic hydrogen, right? So this is an acidic hydrogen and this is a OH group. So removed as water. Okay, and we are going to get an alpha beta unsaturated product like this. Okay, I hope you got some clarity on this reaction steps also. Yeah, so this is our final product, cinnamaldehyde. Okay, right. So now what is the option here? Suitable answer for this? Yeah, so Rosenman reduction followed by Perkins reaction. No. Okay, so here Rosenman reduction followed by Claisen-Smith condensation or reaction. So what is our answer here? Option 2 will be perfect for this discussion. Okay, so this is what you need to know here. And one more thing, in Perkins reaction, what is the product found as a final one? So the Perkins reaction gives you cinnamic acid as a major product. Okay, just remember this cinnamic acid. Okay, right. So let's move to the next question here. Yeah. So the question says alkyl halide, alkyl bromide or aryl bromide here, whatever may be the one. So it is converted into alcohol. But the position of Br and OH is not the same from reactant to product side. Right now, when you compare with reactant and product side, the positions are changed. It means it might be multiple step reaction. Okay, so generally here, if you see the options, first option is KOH alcoholic medium. Okay, and third option also KOH alcoholic medium. So KOH in presence of alcoholic medium, like what happens here? So this favors the solvent here favors elimination. Okay, what will favors elimination? But if you check third, second and fourth option, so there is something like KOH aqueous medium. Okay, so you need to know the solvent effect also. Okay, so in presence of aqueous medium, so it favors substitution over elimination, nucleophilic substitution over elimination. Okay, so let's discuss here. So definitely it's not substitution, because if it's substitution, wherever we have bromine, then OH should come right now, but it is not happening there. Okay, right. Let us go with elimination first. See, if I use alcoholic KOH, what happens here? We are going to get a more substituted alkene like this. Yeah. So this is bromine, and from beta position we can remove beta proton, so that we are going to get an alkene like this. Okay, so this is one of the major product formed by elimination. Okay, right. So the next one here, in the first reaction is oxymethycation demethycation, and third option is hydrobolation. So now what type of products formed here? Very important reaction, these two reactions. In the short form I am calling it as OMDM. Okay, oxymethycation demethycation. So this follows Markovnikov addition. Okay, so just what to do during this process. Okay, so first of all, whenever there is an alkene, during this OMDM reaction, we are adding H2O. Okay, but not directly. Okay, so generally here OH is there means, yeah, we are adding water as a nucleophile, and hydrogen will comes from NaBH4. That is what demethylating agent we will be using here. Anyways, so just listen here. So what I told you, first of all, it forms a three-member ring with mercury, because oxymethycation. No? Then next here it comes OH, and here it comes H. So this is what Markovnikov addition, right? So next one here, if I do hydrobolation reaction, that is from third option, hydrobolation. What is the reagent used here? B2H6, or specifically half B2H6 and H2O2 any of which. So this is what the reagent used. So now what happens? You are going to get something like this. Okay, anti-Markovnikov product. Okay, that's it. Okay, now as for the options, if you observe, the final answer given is looks something like B, something like this second product, right? So what is the suitable answer for this discussion? Yeah, third option is your perfect for this particular question. Okay, hope this discussion also clear with extra points about OMDM, right? And in both of these reactions, OMDM and hydrocolation, there is no rearrangement. Both of them are takes place with concepted states. I mean, with I can say no rearrangement, directly addition. Okay, but OMDM reaction follows a trans addition. Okay, what do we mean by trans addition? The OH group and this hydrogen comes from opposite planes. Okay, when it is in hydrocolation, both OH and hydrogen comes from same plane. Okay, this is syn addition. This is syn or cis addition. This is a trans addition. Okay, right. I hope you got. There is no rearrangement steps involved here. Wherever double bond is there the reaction takes place. They directly add H and H. Now, what will be the product? If I just wanted to add water in acidic medium, okay, so what will be the product formed from these? Please mention the IUPAC name or exactly product. Somehow you tell me the options. Feel free to express your answer even if it's wrong. No issues. Okay, we'll discuss in the chat box. Okay, in the comment box. Okay, so tell me what is this product B formed in the reaction. Okay, just mention the question number and give me your answer in the chat box. Okay, right, in the comment box. Okay, right. Let's move forward with one more question. Yeah. So the question here says alkyne. If you see the question, alkyne is treated with H2 in presence of nickel catalyst. So what will be the product form? Yeah. Let me zoom it out a little bit. Yeah. So what will be the product form here? So it's simple. Only one mole is mentioned. So it means you should clearly get a clue that. Yeah. Let me see the size. clue that you are adding only one H2. It means on this pi bond, you just remove this pi bond and add one hydrogen on this side carbon of alkyne and the another carbon of this alkyne. You just add hydrogen and hydrogen. So it means you're going to get alkene as a product. Okay. So this is methyl. This side also we have methyl. And then next, it is a syn addition. Remember, it's a syn addition. This stereochemistry point of view is very, very important in point of your in your exam point of view. Okay. Then next, if you see this peracid given, okay, peracid is given. Okay, now what happens? This peracid provides one oxygen atom. So that oxygen atom will be reacting with this double bond and forms an epoxides. What they will form? Epoxides are formed. Okay, just remove that pi bond, whatever the pi bond we have seen previously. Just remove that. Okay, and then next add a epoxy bond like this. Okay, the next this is the B. Okay, if you observe this, there is water in acidic medium we have provided. See, this cyclic 3-member ring is a real strained ring now. Yeah. So now what happens whenever we are adding water in presence of acidic medium? See, first of all, this acidic proton will be taken by this oxygen, like protonation takes place and create a positive charge on this oxygen, right? After adding this H plus L. So now ring having more strain with positive charge of oxygen, so that ring opening takes place. So if this side ring is opening, so you are going to see a positive charge on this terminal carbon. Okay. So there, this water molecule will attack. Simple nucleophilic substitution, you can say. And one more tip I wanted to give you is, since the reaction is taking place in acidic medium, you just follow the cleavage of this bond takes place in such a way, like generating a more stable carbocation, something like an SN1 reaction mechanism you can consider. It will be useful when there is unsymmetrical alkyl groups on both sides, because if there is unsymmetrical alkyl groups attached over the carbons of this epoxide, we need to decide which side we need to break this bond, right? So that depends on carbocation stability. Okay, I hope you got some clarity on that discussion also. Right, let's move forward. Yeah. So finally, we are going to get a diol. Okay. Let me add H here, and this side also one H and CH3. That's it. Okay. So this OH came here, and this is a OH coming from this water. Okay. Right. So now the next one, this is our C. No, this is our B. So now this B is treated with what? This B is treated with, if you see here, HiO4, periodic acid. What is it? Periodic acid. So now what's the use of this periodic acid? Yeah, let's discuss periodic acid. Just remember, it is very, very useful when you are discussing about biomolecules. See, I will tell you one simple trick. Whenever there is a periodic acid, see, here we have one OH group and here also we have one OH group now. So just break the sigma bond between them and add one more OH group over here and over here. Okay, it means what you are doing? You are just breaking the sigma bond and adding OH group, hydroxy groups. Okay, right. So let us write the structure CH3, CH, and here two OH groups are there. No? Yeah, let us add for our understanding purpose. Yeah. So like this, we are going to get two fragments. This side one, this side one. So two fragments or two molecules of like germinal diol we got. Okay, right. So now see, upon on same carbon, if you have two OH groups, due to small size of this oxygen, there will be some repulsion between the two hydroxy group lone base. So just you need to eliminate the water. Okay, so you need to eliminate the water like this. See, hydrogen, methyl, and this oxygen. So we are going to get something like this as a final product: CH3, COH. Okay, so this is your final product. Okay. So let's see the options. Do we have anything like this? Yeah, let's see. Yeah, let's see. See. Yeah, up to C we got. Yeah. So up to C here we got. The next step here, if you observe, if you observe, ethyl magnesium bromide is mentioned. Ethyl magnesium bromide. So what it will do? So it's a Grignard reagent, so it can act as a good nucleophile here. So ethyl magnesium bromide. I hope you are very much familiar about this reaction. Okay, right. So this ethyl group will attack on this carbonyl group carbon, and you are going to get CH3, CETH, and this is O minus. Okay. See, if you observe here, they have provided water. Okay, like acidic hydrolysis they have provided, or simply there is a 1 cup and all. So you just need to add this H3O place, and you're going to get CH3, COH, CH2, CH. That's it. So what is the name of this product? See, 1, 2, 3, 4. It's a butane 2-ol. Okay, so butane 2-ol or 2-butanol. So our option 2 will be very perfect answer for the discussion. Okay, so everything I have given clearly. I hope you got some complete clarity on this kind of reactions and concepts. So now I will be giving you one more important concept. See, whatever topic I have discussed here, please remember. See, whenever I am saying that peracid is there, in the given compound, if there is any alkene double bond is there, yeah, that will convert it to epoxy. Remember this shit. And one more thing here, per-iodic acid is given. What is the trick I told you? Whenever there is per-iodic acid with the diols or multiple hydroxy groups are there in the given compound, just break the sigma bond between those two carbons of the hydroxy group containing carbons, and you just add OH groups. Okay, then remove the water molecule, you are going to get the final product. See, now the question in the exam will be like this. So they will give you glucose. Okay. So open chain form for glucose are they just mentioned glucose or something like this. And upon treating with per-iodic acid, now what are the types or what are the products formed? They will say A plus B plus C. Okay. So X number of A's or let's say X number of formaldehydes are formed. Okay. Like Y number of B, let us say Y number of glucose molecules are formed, and Z number of I can say what I can say like formic acid is formed. Okay, like this I will ask you, what is this? What are the values of this X, Y, Z, or the sum of this X, Y, Z? Okay, this is one of the most commonly seen question in your CUET PG level entrance exams, or like CP gate, whatever the exam you are going to write for MSc exams. So this is one of the most important question. The model. Please focus on this one, and you can let me know your answer for this in the chat box. Okay. See, guys. I'm doing this video just to give you complete, I mean, some final revision purpose, and also this will be useful even if you're watching for next year exam preparation. So whenever you're like might be the writing, whenever you might be writing the exam, this session is definitely useful because I'm adding whatever the inputs you require. Okay, right. So the next question here, if you see, which of the following component is not formed during coal-based electrolysis of ethyl propanoate. Okay, so ethyl propanoate, generally propanoate means what? CH3, CH3, let me write CH3, CH2, CO, O minus. Okay, and here ethyl group. So these are ester actually. Okay, but we know like coal-based electrolysis. In coal-based electrolysis, so this part will involve. Okay, so if this part is involving, okay, so this part will go towards anode. So where it goes? Towards anode. Okay. So what do we mean by anode? Which attracts anionic part. Okay. So this is the anionic part. This is attracted by anode. It means anode is a positively charged terminal. So what happens in anode? Oxidation takes place. Okay. So now if oxidation is taking place, so yeah, CH3, CH2, CO, O minus is there. So this electrolysis takes place, and it is going to give you a radical like this. Okay. Now from here, you just remove CO2 gas. Okay, like this, using one electron this side and one more electron from here. So we are going to get a ethyl radical because this electron here, this extra electron, this bonded sigma bonded electron is going to come here as a dot. That is ethyl radical we are going to get. So CH3, CH2 radical. Okay, ethyl radical we got. So from this ethyl radical, what are the possible products we can expect? See, we are going, if there is n number of these units, we are going to get n number of ethyl radicals, right? So if all of them are combined, with each other, we are going to get something like this, like CH2. If every time two are combining, we are going to get CH3, CH2, 1 electron here. Again, one more unit is there, CH2, CH3. Here also 1 electron. So if they combine, you are going to get a bond here, which is nothing but a butane is formed. Okay. So what you are going to get? Butane you are going to get. Okay. Right. So let me discuss few more things. Yeah. Anyways, you're going to get a butane like this. Okay. Right. So butane is the option. They are saying not formed. Yes, N butane is forming. Let us verify other three options also. Now here let us take one disproportionation possible reaction. See what I'm saying is one hydrogen from here, okay, from here, which is joining with this, and you are going to get ethylene CH2 ethylene, and from here you are going to get ethene CH3. So now what are the possible products we got? One is butane, one is ethylene, another one is ethane. Okay, so first three options are possible during this reaction. Okay, but since they are asking about not found, so definitely not found one is N propane. Okay, remember this. And one more important point I just want to mention. See, propane means how many carbons are there? CH3, CH2, CH. Three carbons are there. Odd number of carbons are there. Na? So odd number of carbons containing products will not be found in coal-based electrolysis because uh, odd number of carbons containing alkane, I am saying alkane, hydrocarbon, alkane will not be found in coal-based electrolysis as well as Woods reaction, Woods coupling reaction. Because here two fragments are coupling. If you observe, the major product is somewhat something like this. This ethyl radical will combine to give a major product something like this big hydrocarbon chain. See, even is even, you are going to get even number. R plus R, you are going to get even number, right now. Then how it is possible to get an even odd number of carbons containing alkane? Not possible. Na? So that's why you can simply use this trick and directly choose your fourth option. See guys, I am trying to add uh, tricks wherever it is possible, but actually concepts are very important. Okay, I am discussing concepts, then I am discussing tricks. Okay, so yeah. So after many days, I have again started discussing questions, the concepts or the topics related to CET and other MSc level concepts here. So if you really like the content, please click on the follow button and also please click on the like button. And I want your support during this time because there are very less number of students who watches this kind of content. I mean. Uh, there are very less number of students who prepare for CUT, PG, particularly chemistry kind of exams or any other MSc entrance exams related to chemistry, right? So yeah, if you show the support by sharing with your friends or juniors, whoever might be preparing or going to prepare. So I feel more like supportive and more encouraged to do such kind of videos. Okay, right. So right, let's move forward with one more question here. Yeah. So if you see, ether is there, it is treated with something like one and giving you aromatic product. Okay, treated with two and giving you this kind of thing. Okay, the next three and you are going to get isopropyl. See, cyclic polymerization, definitely aromatic compound from ethane. This is nothing but C triple bond C, H, and H. So cyclic polymerization with ethyl, you are going to get benzene. Okay. So for this, how many carbons are required for benzene? C6H6. It means 3 units are required here. So 3 units of ethylene or ethyl gives you a benzene, 1 unit of benzene upon cyclic polymerization. Okay, so this is our aromatic compound, aromatic product. Okay, right. So these upon treating with some reagent, you are going to get C7. Here 6 are there, here 6 carbons are there, but here in the final product, C7, H6, same number of carbons, and one oxygen is there. See, they have mentioned here ETOX oxidation. Yeah. See, ETOX oxidation requires chromyl chloride reagent. What is that? CrO2 Cl2. Chromyl chloride CrO2 Cl, chromium chloride is the reagent used here. Okay, so this chromium chloride converts the alkyl benzene to benzaldehyde or aldehyde kind of products. But here we do not have any alkyl benzene. This is a simple benzene, so it's not a E-dots reaction. Okay, definitely Gattermann-Koch reaction is. Okay, so our option will be in between 1 and 4. Let us discuss. Okay, so Gattermann-Koch reaction is what happens here. H2 or HCl plus CO in presence of anhydrous AlCl3. Okay, so CO, HCl, anhydrous AlCl3. You are going to get a benzaldehyde. Okay, so benzaldehyde has how many carbons? 7 carbons. Okay, so this is your product B here. So now these, upon treating with third compound, you are going to get an isoquinoline. So isoquinoline you are going to get. Okay, so these reactions particularly Pomeranz fits a reaction. What is the name of this reaction? Pomeranz fits a reaction. Okay, so yeah, so it means definitely our option 4 will be perfect. See, Bichler's Naplierski is also used for quinoline or isoquinoline preparation, but here it is not the one to be used. Okay, so now once just go through this kind of reactions, you might be not familiar with this Naplierski reaction as well as Pomeranz reaction, and here one more name reaction is a Doebner-Miller synthesis. Okay, because see, there will be a lot of name reactions, and after that, we will cover almost some 40 50 name reactions in our daily discussions. Okay, but even though we cover that many, we may expect again new name reactions. So we can't do anything in that case. So just wherever or whenever you see some new name reactions in the question papers, previous papers, you must cover it. Okay, right. So this is about the discussion. So yeah, so in the upcoming session we'll cover a few more questions. If you like the content, please share, subscribe, and do follow. Please share your feedback of up for upcoming sessions. So we will be considering them and we will be making according to them. Thanks for watching. Stay connected. Do very well. Prepare. Okay. Thank you.